Very legible. I
All
like
right.
it.
Thumbs up across the board.
Looks good.
Mad Pass. What do you think?
That ASCII text looks awesome.
That is my trademark. If you steal it, I'll come after you.
I hope I learned something
Yeah.
from that today.
Yeah. I got lawyers whose face masks have face masks. They'll come for you tonight. All right. So I'm Erik. Spotlighted my video. Oh, look. What? Thank you. Whoever did that. I appreciate it. I'm in the spotlight now.
This is a professional operation.
So first, everyone, cheers. Here's to a successful meeting. We're hopefully all happy and healthy and getting along well, despite having been indoors for about a month. I gave myself my second pandemic haircut today. You can probably tell. It's not my finest work, but don't worry. After this, I'm not planning on going into the barber industry anyway. I'm probably going to stick with the SQL Server thing. I don't know. Maybe I'll give Jake a haircut next time I see him. I don't know. We'll see how brave. Last time I saw him, I got to give him a neck tattoo. So we'll see how brave he's feeling on the next one. So if you want to get in touch with, I'll show this again at the end too. If you want to get in touch with me, all of my contact info is right about there on the slide. You can't really see where I'm pointing, but I'm sure you can see letters and stuff. If you want to see a fully recorded version of everything that I'm going to be talking about here tonight, you can do that. I have recorded all of these demos and more without screaming children in the background and put them on YouTube. So if you want to go look at these some other time, I might add more content to this. I don't know. I'm feeling a little frisky. It's not like I have anywhere to go. So I might add more content to this stuff later. We'll see what happens. So if you want to go to that bit.ly link, just remember that bit.ly link is case sensitive. So mind your E's and I's and T's on that. And because I love you all so very much, and because I had such a nice time when I was in Madison, I have recently launched my own video training stuff online. It's at learn.erikdarlingdata.com. And if you enter the coupon code Joe Obish, you will get 50% off anything you buy. Anything. Anything. Doesn't matter how much or how little, 50% off the whole thing. And it's not because Joe wrote half of the material, it's because he hates half of it. So because I say the word Sargable too much and Joe gets angry at me. So anyway, let's actually get started talking about something that has to do with SQL Server for once. So the first thing I want to do is talk about sorts. And I think that we can all agree, if we have ever looked at a query plan or ever looked at a slow query, that we may have seen a sort operator, and that sort may have been up to some nonsense. There's lots of nonsense that sorts get up to. We care about them for a few different reasons. When we see a sort in a query plan, we know a few things. We have identified a few things mentally. We have asked for memory. That memory has to come from somewhere. Usually that crappy VM admin of yours who won't give your SQL Server enough memory has no idea that SQL Server has to share memory between the buffer pool and queries that ask for memory. And so when he's like, 8 gigs is plenty. Well, you might want to, I don't know. If you ever see that VM admin again, you might want to hit them with something sturdy. We also know that sorts might spill the disk. Erik might spill his drink. Sorts might spill to disk if they don't get enough memory. That's a really common thing that might happen if you hit a parameter sniffing issue. And of course, they do make code more sensitive to parameter sniffing because the more like if you ask for too little memory on one, then you're probably going to spill the disk on a big one. If you ask for too much memory on another one, then you're not going to use it on another one, and you're going to clear out a whole bunch of stuff from the buffer pool, and that's no fun. So let's look at how we can start fixing sorts with indexes, because indexes are a grand way. I mean, they're not free, but they're a pretty awesome way to fix issues with sorts. What I'm going to do is, well, I've already created this index, and I can tell because through the marvel of advanced IntelliSense technology, I have little red squiggles under that index name. So we can tell that I've already created that. Now, this is not a regular index. I'm kidding. It's absolutely, it's probably like below par, below average index, but it does have 4 key columns. It's got reputation, upvotes, downvotes, and creation date. And the key of the index, remember that. 4 columns. Cool. If I want to show you, and I do love showing people these things, just how indexes put things in order, it's something like this. Now, within any B-tree index, the data is ordered by the key columns in the order that you have them in the key of the index. So whenever you have duplicates in a column, any column to the right of that will be in the order of that column within that duplicate range. So for this query here, where we have reputation being reputation 124, we start to see a pattern emerging in the data. If you don't, then go home, you're drunk. But we start to see this pattern emerge where for 124, we then have upvotes, and then we have downvotes, and then we have creation date. So, and this will repeat all the way down. So for every reputation of 124, then the upvotes column will be in order next. The downvotes column will be in order after that, right? So for any duplicates within upvotes, we'll have downvotes. And then for any duplicates within downvotes, we'll have creation date in order descending after that. And we can take that knowledge, we can take what we understand about the way B-tree indexes store data and use that to help us start getting rid of sorts in our query plans. So if I run these two queries, we will get two different things back from our good friend, that the XML artist known as SQL Server. We will get two different query plans. The first one up top is going to have a sort operator in it right about here. All right, we can see that SQL Server had to break out its tiny little, its expensive baby hands and start sorting data for us. In the bottom query, we only have an index seek and then a top. There's no top and sort there. The reason why those two query plans are different is because of the way I wrote these queries and had them navigate that B-tree structure. When you look at when you think about B-trees, I like to think of them like Tarzan, where they can swing from column to column, but if you try to swing a column too far, you're gonna smack into a tree. So in the first query, I'm just selecting the top 1,000 ordered by upvotes. And upvotes is the second key column. And this is where Tarzan hits the tree and has to sort that data. In the second query, I have an equality predicate on reputation, and then I order by upvotes. So because we get right to all the entire spot in the index where reputation equals 1, we have upvotes in order after that. And so we didn't have to break out our expensive baby hands and sort data to put it in the order of the upvotes column here. We can do that with the entire index. We can use the entire index to our advantage. So if I run this query, where I am also, everyone's excited about this. If I run this query where I have a where clause on reputation and then upvotes and then downvotes and I order by creation date last, I still won't have to sort any data because I will have Tarzaned my way through the B tree all the way to the last column. And look at this. We don't have to sort data. We have our data in order the way we wanted it, right? Pretty sweet. So when you start seeing things like sorts and execution plans, I want you to pay attention to them. I want you to pay attention to what you're sorting by, and I want you to pay attention to how your indexes are set up, because often we can adjust some indexes to make better use of them and stop having to break out our tiny expensive baby hands and clear a bunch of stuff out of the buffer pool because our VM and min won't give us enough memory, and start sorting data with our indexes. Now, one thing I want to point out about indexes, though, this is one thing that we should all know about them, is that aside from being able to display data, aside from being able to just hand us some data in whatever order, includes are just basically window dressing, right? They don't help us put any data in order. So I had display name as an included column in the index. But when I run this query and I select the top 1,000 and I look at the execution plan, I still have to sort that data because display name does not help us as an included column put anything in order. There's another problem too. We talked about equality predicates, and that's great. Equality predicates are fantastic, but no one ever wrote an entire query with just equality. I mean, I wish they would, because that would make my life as a consultant very easy if everything was just equality predicates. But as soon as we start looking at inequality predicates, right, and that's by inequality, I mean anything that's in a range. So greater than, less than, greater than equal to, less than equal to, not equal to. These are all inequality predicates. These are all range predicates. And when we start dealing with these, then our index order stops being as useful. So here I'm going to look where reputation is less than or equal to 1 or greater than or equal to. If my college math is correct, that is 1,000,000. Jake, can you confirm? As a mathematician, that's 1,000,000?
It is.
It is. Beautiful. Okay, great. So if I run these two queries, thank you, I appreciate that. You're worth 1,000,000 reputations to me, Jake. If I run these two queries, both of these execution plans will have sorts in them because those inequality predicates throw SQL Server for a loop. It's like, I don't know. I just don't know anymore. I don't know what order this data is going to come back in. I'm scared. I'm alone. I'm naked. I just don't know what I'm going to do anymore. There are some fun ways that we can work around that. There are some interesting things with the way that SQL Server thinks differently about indexes, though. So, like, if I have reputation as the where clause and I'm filtering on it, and then the order by, well, all of a sudden SQL Server is like, this I got figured out, no problem. The other nice thing is that if we need to filter on columns that are much later in the index, so like where up votes is greater than or equal to 1,000,000, or where down votes is less than or equal to, wait a minute, 100,000, off by one, the saddest computer error. So if I run these two queries where I'm searching for data that's much further over to the right in the index, but still ordering by the key column, then SQL Server also can figure out some things and not have to sort our data. And I think that's pretty handy. So what I'm going to do is talk about a slightly more interesting predicate. I have to start creating this index and then start talking about some other things, because this index takes a minute to create, and I can feel my computer fans kick in when I do it. So we have this query here, and this is kind of a funny, I think it's funny, but I spend a lot of time staring at SQL Server. So what I'm going to do is select some stuff from this table called votes. And vote type ID is just not a very selective column. There are lots and lots of rows in that. Was like 53 million rows or something in this table, but a lot of them are between 1 and 3. So we're looking for vote type IDs of 1 or vote type IDs of 3. That's the first thing in our where clause. The next thing in our where clause is this inequality, where creation date is greater than or equal to 2010-0101, as long as I can still read, and I'm pretty sure I can. But we're going to do something a little bit more interesting here, and we're going to generate a row number. And it's something that happens a lot in queries that people just take for granted are these windowing functions. Everyone in the world will have read some article that's like one of, I don't know, 40 articles in the internet about how awesome window functions are. You just write them. The analysis queries are perfect. You just don't worry about anything. They're great the way they are. But you do have to worry about indexing for them. Because when you don't index for your windowing functions and you have to go and then run queries that have to analyze a lot of data with those windowing functions, all of a sudden they can get very, very slow. This happened to me a long time ago. Now, I pulled a funny trick on the optimizer here. There's a very, very funny trick that I'm pulling on the optimizer. And outside of this initial common table expression, I'm filtering where the row number equals 0. Row number can't generate a 0, but the optimizer isn't that smart. I'm smarter than the optimizer. That's why I'm here talking to you about it. So with this index finally in place, I'm going to run this query, and we're going to look at the execution plan together. And rather than see the optimizer doing what I would do and say row number can't be 0, we're done, SQL Server is going to run this whole thing. And SQL Server is going to sort a whole bunch of data. Why? I know you probably feel like I lied to you, because we have our index set up in just the way that we would want. We have our equality predicate first. We're in 1-3, and then we have our order by here. Right? We're going to have to order by post ID. It says it right here: partition by post ID, order by bounding amount. Those are the next columns over in the index. And then we have creation date dead last, because creation date is an inequality predicate, and SQL Server freaks out and has to sort data when we have inequality predicates. Turns out even though it says we're doing an index seek, and even though it says right there on the screen that we sought to scalar operator 1 and we sought to scalar operator 3, we still had to sort a whole bunch of data. Well, the sad thing about is that inside, deep down inside, SQL Server thinks about it like OR, and it does these weird range seeks. It does not just seek exactly to 1 and then exactly to 3. If we want the query plan that we're after, if we want a sort-free query plan based on our indexing knowledge and based on what we want from this query, we have to break things up a little bit. And by break things up, I mean we have to use my best friend in all of query tuning, union all. I love it's like I can't tell you how many problems I solved just with union all alone. And when we run this query, where we have one query that will look for vote type ID equals 1, one query that will look for vote type ID equals 3. We will get exactly, I mean, not like exactly, but we will get a query plan that's much closer to the one that we were looking for that has no sort operator. We're able to seek to vote type ID 1. We are able to seek to vote type ID 3. And then we do not have to sort data anywhere in here. SQL Server has the data in just the order it wants. So do I hate in? Mostly. But more importantly, I hate sorts. And this is one way of dealing with unfortunate sorts and execution plans, especially as we start getting into more advanced T-SQL, like windowing functions and all that good stuff. Are there any questions about that before we move on to the next thing? I mean, anyone can just unmute themselves and do something raunchy.
So I'd also like to just point out to everybody, just because we do have a ton of people on too, if you want to just type in questions into the group chat, if you're not comfortable just interrupting, although I think Erik is fine with interruptions.
Yeah,
you can type them into the group
me.
chat and I'll interrupt him so he can get pissed off at me instead.
Yeah, because I'm not paying attention to group chat right now. I apologize.
We got another question. What
was the first question?
The first question was, don't worry about it. The second question is, if you set x.r equal 1, will the plan change at all?
No, I'll just get results back, and I want to avoid that.
Sure.
Anything else?
Not at the moment.
All right, cool. I'm gonna close this one then, and we're gonna go talk about memory grants. So actually, first, is Lonnie on here?
He is.
He is. Okay, so Lonnie, you're going to like this one. So what I'm going to do here, the first thing I'm going to do is I'm going to set my page file size to 0, because this is the best performance enhancement in all of SQL Server.
Lonnie just dropped off as soon as you asked if he was on.
I know, because he's gone to have a stroke.
He's like, enough of this.
I'm kidding. Don't do that. It's a bad idea. It was a joke, and I don't know. Lonnie
equals 0. I'm with you.
Yep.
Oh, you are? Okay, good.
All right, so let's talk a little bit about memory grants. I already get query plans turned on because I am a professional. So building a little bit on what we just talked about with sorts, right? We looked at it like how indexes can help them. Let's look at why we care about them and just why we would want to spend this time thinking about indexing and thinking about getting rid of sorts and execution plans with an index. Now, if you're using column store, basically none of this matters. But if you're an old sap like me and you're working with OLTP and row store indexes, then this is just stuff you have to care about. Once you move to column store, I hear you just don't have to worry about memory at all. It's just all fixed. I'm kidding. It's all screwed. I've seen charts and graphs on Twitter that prove how messed up it is. So let's look at this one. This query is going to ask for the top 1,000 IDs in the users table, ordered by reputation. And I'm setting maxed to 1 just to keep things simple up front. So I'm going to run this query, and we're going to look at the execution plan together. And we are going to wonder out loud, Erik, I mean, just think of me like SQL Server. Erik, what happened? What happened in this query? Well, this query had one memory consuming operator, and that is this sort right here. And because we had to sort that one column by the reputation column, we asked for 166 megs of memory. Is the text size on that good, or is that tiny? It's good.
I think it's good if you're watching full screen. It was fine.
All right. Well, everyone watch full screen then. Otherwise, you're screwed. So having to sort the table and get data in order by reputation, because I don't have a supporting index on reputation. I don't have a way for SQL Server to already physically have that data in the order we want it in. I need to sort that data, and SQL Server needs memory to write data down in the order that we want it in. I know that I wrote that query in kind of a silly way, but it'll make sense in a minute when I show you this. I'm going to have 2 top 1,000s in this query, and I'm going to join them together. And I'm going to let SQL Server pick the join for this one. And when I run this query, where we have 2 sorts. Now, normally, if I was in front of a group of people, and I would ask for a show of hands or some quick audience feedback, but I don't have that luxury. I'm talking to all of you as socially distanced as I could possibly be, I think, unless I got on an airplane, which would just mess the whole game up, right? But when I run this query that has 2 distinct areas where I will need to sort data, the execution plan is going to have 2 sort operators in it. One on top, one on bottom. I'm not judging, just where they are. If we look at the memory that this query asked for, it is not 166 times 2. It's only 167.8. Why? Because SQL Server is kind of a smart cookie occasionally. In this query plan, these two sort operators were able to share memory. We have this sort up here, and this sort was able to get the memory that it came for. And if we can find that out by looking at the properties of any operator that needs memory, this sort was going to have something called memory fractions. Now, memory fractions are a little weird to read, especially when you start looking at them for hashes. We're not going to talk about that. It's days of your head not working. But if we look at the memory fractions for a sort, the number 1 basically means 100. So this sort got the 100% of the memory grant, and it passed out almost the entire thing. Now, we have something interesting in the query plan next. We have a hash match. We have a hash match for the join. And what this means is that SQL Server had to stop here. Just like sorts, hashes are a blocking operator. I don't mean that they're blocking other queries. I mean that internally, SQL Server has to get all the rows there, and then when all the rows arrive and it builds the hash table, it can start using that hash table to probe the inner side of the join. So we have this stopping operator here. Now, hashes also require memory, just kind of not usually the crazy amounts that sorts ask for. On the inner side of the query, after the hash join, this sort operator is going to see, we're going to see that this took the entire memory grant that this sort passed out, 0.998076, used that, and then gave up the rest. So we did not need to double our memory to have the two sort operators in this plan. Where this goes wrong, I have to scroll all the way back over here for some reason. Where this goes wrong is if I tell SQL Server, you are wrong about that, we're gonna do a loop join here. Now, loop joins are not blocking operators. So in this case, we're gonna do things a little bit differently. And if we look at the execution plan, this time we will need 333 megs of memory. All right, cool. Does anyone care about 333 megs of memory? I don't. My laptop, I have 64 gigs of memory, and the thing that I kick when I get angry at it, because it gives me wrong results, I have 128 gigs of memory. Let's look at where that can get bad. Let's look at where memory can go bad. So what I'm going to do is not run through all of these because I respect your time. I respect you as individuals who probably have things to do. But if I start adding some string columns into the equation, if I start telling SQL Server, we need to not only sort that ID column by reputation, we need to sort some of these other columns too. And when I do that, just to get the top 1,000 out of this query, SQL Server will ask for a whole lot of memory to do that. If you're looking closely and you squint your eyes, you'll see that is 9.7 gigs of memory to get 1,000 rows out of this table. Because the way that SQL Server sorts data probably isn't the way that you would want it to. A lot of people will think, I order by reputation. I'm just going to write reputation down in the order I want. Wrong. Absolutely incorrect. SQL Server not only has to write reputation down in the order you want it in, it has to write all of the columns you're selecting down in the order you want reputation in, and it will ask for memory to do that. The bigger your data set is, the more memory SQL Server will ask for. That goes for both the lengthwise, the number of rows that you're asking for, and the width of the data. Some people will call it the girth, but I feel gross when I say that. So the width of the data will also matter here. You can see those columns that I'm selecting are strings. Display name, website URL, location, and about me. About me is an varchar max. SQL Server makes some really wild guesses about how much memory it's going to need for string columns. It basically is going to guess, no matter what reality is, that every single one of them is half full. It does that so that if you have some that are not very full and some that are very full, what can you do? You landed somewhere in the middle. Okay, good general guess. But man, can you end up with some nasty memory grants because of that. Now, the last thing that I want to point out here is that memory grants are not really affected by parallelism. When you have a parallel execution plan, that parallel execution plan did not start that way. It started as a serial plan. Every execution plan starts as a serial plan. SQL Server says, I'm going to figure out how expensive you are. And if that serial plan is more expensive than your cost threshold for parallelism setting, SQL Server will start examining parallel plans for that serial plan. And then if the parallel plan is cheaper than the serial plan, it'll pick that parallel plan. And if that serial plan needed a memory grant, SQL Server will take that memory grant and split it evenly amongst the threads in that parallel plan. I'm simplifying a bit, but you get the idea. So if I run this query, which is going to run at max.8, it's not going to be the memory grant times 8. Every thread isn't going to need its own memory grant. SQL Server, the way it splits up parallel queries, it says, look, you're all equal. You're going to do equal amounts of work. You all get equal amounts of resources. So if I run this query and look at over at the memory grant, it's about 181 megs. Yes, there's some overhead because we have parallelism. Parallel exchanges need a little bit of help passing rows and threads around all their crazy little buffers, those CX packet things that people on Stack Exchange get all worked up about. And yep, we have our sort, we have another sort, we have another hash match, but it doesn't go up to like 900 megs or something. It stays at a pretty reasonable 181.6 megs, which is okay with me. But it's something to keep in mind that parallel plans do not ask for like crazy amounts more memory than serial plans do. Are there any questions on that?
Yeah, can I jump in with a question? I noticed you had sizes by the individual columns.
Yes.
And there was a surprising size there. There was a 100, an NVARCHAR 100.
Yes.
That was larger than the NVARCHAR 200.
Oh, so that was the total grant. That was not like each individual one. That was if I quote those out and run them in and tag them in order, then they will ask for a larger and larger grant.
Right. Okay, I get it. All right. Excellent.
Yeah. I tried to do the individual one at first, but it was far less compelling.
We do have a general question.
Oh, okay.
I think when there's an opportunity to do so, could you talk a bit about what are the differences between memory, CPU, and I/O, how SQL Server uses these resources?
No.
I think that might be getting a little bit too...
That's if you have a week, sure. that's my pre-con.
Okay.
I wish I had that kind of time on my hands. No, in an hour, I just can't do justice to that. I'm sorry. If you have a more specific question, I would be happy to answer it. It doesn't even have to be about what I'm presenting, just something more specific than like, how does a computer use resources? Guesswork. Same way we all do. All right, so we talked about memory in a couple different ways, right? How SQL Server will use it for sorting data. And now let's talk about how SQL Server will use it to cache data, right? Because that's the other part of the equation. It's like when I think about like the holy trinity of ways that a SQL Server will use memory, most people will think about the buffer pool, right? Where SQL Server stores all those pages so it doesn't have to go to those nasty disks. Memory grants, which you just looked at, where you have to sort data. SQL Server will ask for memory to write stuff down in. And then probably the plan cache if you're that kind of weird person who does like analysis on servers. So let's look at the other, let's look at like something else. Look at the buffer pool, right? Because the buffer pool is a pretty neat place, and it's, how you avoid going to disk, which I hate doing. It's slow, so slow. So I have a couple of helper views here. This one, which is called What's Up Indexes, will tell me what my indexes look like. In this case, just for the users table. That's all I care about right now. We can get some information about that. And I also have a helper view that will tell me what's currently in the buffer pool, which is nothing right now, which is amazing, right? End users will ruin everything. They'll come along, they'll fill it up with crap. So what I'm going to do, and this is kind of a fun demo, is I'm going to run that query to look at indexes. I'm going to clear the crap out of everything that is a memory consuming pool on my SQL Server. I'm going to look at what's in memory. I'm going to turn on execution plans. I'm going to select a count from the users table. I'm going to turn query plans off. And then I'm going to look at what's in memory afterwards. All right, so I'm going to do that. I'm going to hit F5, and we're going to start getting some stuff back that we can look at, and it's going to be fun and exciting, and then we can, well learn something together. Because I learn something every time I do this, because I usually get drunk and forget what I did the first time. So what we have is, oh yeah, because never mind. Yeah, I just learned that if I have execution plans turned on, the set statistics XML thing doesn't do anything. And I was like, where's the query plan? I'm like, oh yeah, it's up top. So we have this, we have the top result, which tells us what our index looks like. right? And we can see that for the users table, we have about 2.4 million, well, let's call it 2.5. I'm willing to round up on that. 2.5 million pages. Anyone who's like cares about math, please don't pay attention much. And then I can see here that the number of pages that are assigned to the users table is 4,447. This table takes up about 350 megs of space, with some space for lob and some space for row overflow. The count query gave us exactly the number of rows that are in the table back. The execution plan for it, this is why I do it the other way. I'm going to turn that off. But the execution plan for our count query is a scan of the clustered index. And what ends up in memory when we're done is the entire clustered index, sans the row overflow pages. We don't get that stuff, but we do get the 347-ish megs of actual data in there. Now, that sucks. We had to read the entire clustered index into memory just to get a count. That's annoying. Where things get a little interesting is, let's say that we want to filter data, right? So let's quote that in, and let's quote this out. I always think of professional wrestling when I do this, like tag teaming things in and out. But let's do this, and let's look at what happens if we filter data, right? So we're going to do the exact same thing, except this time we're going to have a where clause on our query, where reputation is greater than or equal to 100,000, right? When we look at what happens here, right, we get the same result back. We see that our indexes have not changed, thank God, since we last looked at this. We get 613 rows back this time, far fewer than 2.4 million. And our query plan is still a scan of the clustered index, right? We still have that going against us. And because we still have that going against us, then we still end up with the same amount of data in memory. Now, where things get kind of cool and interesting is if we switcheroo these again, right? So we're gonna boom, ba boom, and then boom, ba boom. Now let's add an index to this table. Let's add an index that is not our clustered index. And let's have it just coincidentally be on the reputation column, which is also what we're gonna filter on in the future. I promise. I didn't just make this up. So with that index in place, what happens to our queries now? Well, things are going to change a little bit. This first result is going to show our new index. And because this non-clustered index is not the clustered index, meaning it's not everything going on in the table, Jake, stop texting, we can see that the non-clustered index is much smaller. It's much more densely packed on these pages because we only need to write down the reputation column here. So we have a much smaller index that still has the same amount of rows in it. Right? That's still good, right? We can still get the count from there. And we can see SQL Server is smart enough to use that index and read much less data into memory, right? It's about 10% of the memory that we needed just to get that count. Now, we have a scan of that non-clustered index here. I'm not opposed to scans. Scans are perfectly good. If seeks were always faster, then SQL Server would only have seeks in them. Sometimes you need a scan. Where seeks can be helpful, though, is when we do something like this. So let's tag this one back out, and let's tag this one back in, and let's rerun that experiment, and let's look at what SQL Server has in memory when we finish this. So remember, this non-clustered index is about 4,200 pages, and when we have a where clause that only looks for a portion of that index that we can seek to, then SQL Server can read far less data into memory. We can see the end result here is that we only have a tiny portion of that index up in the buffer pool now. Now, sure, if your where clause starts getting bigger or you start looking for different ranges or different reputations, you'll read more and more of that index in. But if we want to help SQL Server make the best possible use of the limited buffer pool memory that your crappy VM admin will not give you more of, this is a very, very good way to do it. Having the correct indexes to help your queries find the data they need. Also, not relying on clustered indexes for all those completely malformed tables where your developers stuck a bunch of varchar max columns in because they were afraid of those nasty truncation errors. So you'll have two things going for you there. Anyway, are there any questions on that?
We do have a question coming in.
All right.
For the cost of the query shown in the query plan, does the percentage mean memory?
No, the percentage is a completely arbitrary metric. It has no real life correlation anymore. Percentages and costs are a generally unhelpful thing to look at if you're looking at a query plan. Sometimes they're right, sometimes they're wrong, but at the end of the day, they're estimates. Like if you look at a query plan, right? If you hit Control and L, or you hit this button up here, and you get an estimated execution plan, you will get a whole bunch of estimated costs in that query plan. If you turn on actual plans and you run your query, you don't get any update to those costs. The costs don't change. The costs and everything else are still just estimates. Now, you'll get some actual feedback back. You'll get something like rows return, rows read, all that other good stuff, but you will never see an update to any of the costing metrics, because the cost of things SQL Server doesn't think about again. SQL Server wasn't like, oh, that turned out to be 99% instead. SQL Server is just like, no, that's my guess. I'm sticking to it. I don't care what you think. It's like when I do taxes, I'm like, no, I don't think I owe that much, and I'm sticking to it. It's just the same thing. All right. So long story short, don't put a lot of faith in the percentages and estimates, and they don't really relate to anything that you'll care about. It's all just internal optimizer stuff. They're like an okay reference point, but they're not like the end all be all of trying to tune a query. Much more important things I'd look at. So anyway, let's look at how a read query can block a write query. So I have this store procedure, and what I'm going to do with this store procedure is intentionally get myself into a parameter sniffing situation. Because, I mean, what the hell? It makes for a good demo. I don't really have a practical reason beyond that. So what we're going to do for this query is we're going to get a bad plan. And by bad plan, I just mean this plan is going to be bad for this parameter, because they are decidedly different chunks of time. This is 2013, 12/31, and this is the beginning of, Jake, say it with me, which calendar?
It has something to do with, like, they removed.
You went to college. Damn.
Yeah, they were like removed
The Gregorian calendar.
Yeah, but they removed weeks from 1752 or something.
There were
right?
11 days missing from.
Yeah, so that's why it goes back to 1753.
Yes, and that's why one of the first riots on record was the English calendar riot of 1752.
Was it really?
Yeah, they wanted their 11 days back.
Wow.
Yeah.
Wow.
Yeah, I know. Who said this was just SQL Server? You're going to learn all sorts of interesting things here. So I'm going to run this query, and this query is going to get an execution plan for itself that is not bad. That finishes in 0.006 milliseconds. I am okay with this query plan here. I don't care that this costs 98%. That's fine. If something costs 98% and it takes 0.003 milliseconds, guess what I'm not tuning? That 98%. that 98% can stay. That thing can hang out all day long. Where things get a little bit worse is if I reuse that execution plan for a larger amount of data. Now, while this thing runs, I'm going to get a couple other windows set up because I am a professional, and I've been told that this is the way that professionals do things. So I'm going to get some other queries, some other query windows set up here, and they're going to help us figure out what's going on in this demo. So this thing here is going to run for just about 9 seconds. Now, something kind of interesting is that that is still 98%, but it's still only about 4 seconds of the execution plan. So I don't know, see, these costing numbers are all wacky. Don't get hung up on those. We got 2.1 seconds here, which is 0%. So you can kind of start to figure out where these things fall apart very quickly. They don't always deal well with reality. We got 3.9 seconds here, and then in row mode plans, these numbers add up from right to left. Just about. There's some weirdness, but usually they add up if you go from right to left. So if you just think about 2.1 plus 3.9, and then plus whatever the nested loops join did, and then we finally get to our sort. And this is about 9.5 seconds of execution time. Okay? 9.5 seconds. Now, this is where things get weird. In this window, I have SP who is active, which is going to, with the get locks parameter, which is the most helpful parameter one of the most helpful parameters. If you don't know, if you've never heard of this store procedure, you can go to that URL and get it. And over in this window, we have an update. We have a begin tran, right? We're going to update the votes table, and we're going to update the whole thing. Because I know, I just want to exacerbate the situation so that you can see what happens. So what I'm going to do is I'm going to rerun this query that runs for about 9.5 seconds. I'm going to run this. 2, 3, 4, 5, 6, 7, 8, and I'm going to look over here. And I'm going to come here and hopefully kill that before anything terrible happens. But we're going to come back over to this window. We can see this thing ran for about 9.6 seconds again, right? We got that figured out. We go roll that back just so I don't forget later. But over in this window, we're going to see something kind of interesting. If you've ever looked at SP who is active output before during a blocking situation, you've probably seen something similar but reversed. Because in this situation, we have a select query. That's this thing. There's no magic hidden other text in here. There's no other stuff going on in this batch. That's all it is. And it's blocking this modification query. Right? So we're trying to update the table. That update is blocked. Right? If you look over here at the blocking session IDs, we shrink that down a little bit. We'll have this blocking session ID column. And what's happening down here? 57. Right? You can see the blocking, and what's 57 is our read query. But why? Why were you stuck for here 8 seconds? If I was just 100 milliseconds better with that F5, we would have had 8 seconds on the nose. It's shameful. This is gonna be my last presentation. I quit after this. This is terrible. But anyway, we see that read query had been blocking that modification query for 8 seconds. The reason for that is back in this execution plan, and the reason for that is right here. When you have a key lookup, or even a bookmark lookup, if you're the kind of person who eschews clustered indexes, if you have a lookup in your execution plan, SQL Server needs to take a very special kind of lock when it does a lookup. And that lock is called a shared lock. Not intent shared, just shared. And when we end up with an object level shared lock, like we will when we do a key lookup, SQL Server holds on for that lock, not just for the duration of when we're doing the key lookup, but for the entire duration of the query. So if you ever are in a situation where you're looking at a blocking chain and you see a select query up at the top, I guarantee you, 100% of the time, there will be a lookup in that execution plan. And if you're looking at SP who is active and you use that get locks parameter right there, if you scroll over a little bit to the right, you'll have this column of locking information. And if we look over here, over on the votes table, we are going to have an object level lock that's shared, and it's going to have been granted, right? So SQL Server took that lock got granted, and SQL Server will hold on to it for the entire time that query runs. If we look at the locks that update wants to take, it's a similar lock, but this one is waiting. So SQL Server wants an object level lock, but this is only intent exclusive. This is like, I need to do something, and SQL Server is like, you can't. You're stuck. You are being blocked by this read query. I was told that would never happen. So under like normal circumstances, SQL Server would, if for a read query, start taking locks and let go of them immediately. Like any other time you have a read query, it's just, doing a little dance down the B tree and reading stuff and immediately letting go of it. Here, not so much. It's going to hold on to that lock for however long your query runs for. So if you end up in crazy situations where you have query plans like this that are sensitive to parameter sniffing, where they have key lookups in them, and they run for a long time, they can end up blocking modification queries on the inner side of that key lookup, which is just nuts. Now, this is solved by a number of things like, fixing key lookups or optimistic isolation levels. But the important thing here is that if you are out in the real world and you see this, that is most likely what is happening here. I can pretty much guarantee that that's what's happening there. Any questions on that, or in general?
Another question coming in here. How do you tell which query processes more data?
Stare at it. I'm not really sure what the question is getting at there. If you mean like in a parameter sniffing situation, you don't get a lot of help from SQL Server. So like, when you look at the plan cache or you look at query store, you get whatever the initial query plan was, or rather whatever the initial parameters were and whatever the query did initially. and for subsequent executions, unless there's a recompile, you don't see what was happening with them. Like you don't get the new parameter values. You don't get that SQL Server did more work from the query plan, but you can kind of tell from the DMVs if you like sort of average things out over executions. You can kind of start to figure out if like on average some queries do more work than others, but there's still no like silver bullet like, oh, it was this set of parameters in the bedroom with a candlestick and a dustbuster that killed performance. It's all just a lot of like, you know, a lot of monitoring and staring and, you know, getting sort of anecdotal stuff from end users like, so what parameters did you set that store procedure off with? Oh, cool. Let's go see what happens now. And like, you know, sort of comparing what happens when you go hit F5 and like see what actually goes down. Cache plans just aren't a lot of help for that. All right. So Jake personally asked for this one, so I better do a really good job here. All right. I better do like a really excellent job. I better sober up for this one. So this is all about bitmaps. And bitmaps are these kind of fun, like, I don't know, no one ever really pays a lot of attention to them. It's like, oh, they happen, right? Because you look at a query plan, you're like, bitmap, I don't know. Sounds like college. So we got here a query that does nothing but provide a good demo. Most of my queries are like that. I don't know, you can go call them unrealistic on Twitter or wherever later. It's fine. They do what I want them to do, and they show what I want them to show, and that's the end of the story. When you go write demos for a living, just kidding. So let's look at this. Let's look at this query first, because this query is a helpful bitmap. Now we can see where the bitmap gets created in the execution plan over here, all right? And that's true. That is where it gets created, but only where it gets created. That's not where it gets. That's not where it gets used by the query processor. Where a bitmap gets used is not here. It is somewhere below here. So in this case, because we have a well-formed bitmap and we don't have anything weird happening down here, this bitmap will get used at the clustered index scan. And if this tooltip will cooperate and show up, we will see a predicate in the tooltip, and that predicate will say probe something 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 bitmap 1004 in row. And so SQL Server took the bitmap that was created up there where it was keeping track of user IDs, and it will take the user IDs bitmap and we'll push it to the index scan. And then before pages even come off of disk, SQL Server will take that bitmap and apply it to every row that's coming out of there. And we'll say, you pass, you don't, you pass, you don't. This is an effective bitmap. We can tell it's an effective bitmap because SQL Server is saying that I think I'm going to need to read 2.4 million rows. I think that I'm going to need a lot of these rows back, but then look how many we actually read. 83,000. That's that bitmap at work. That bitmap is before we had to read every single row from disk and process it inside of the query. SQL Server applies that bitmap filter and says, no, you don't need to even leave disk. You can just stay right where you are. Thank you. So that's a useful bitmap because we're able to take a situation where SQL Server was like, shoot, man, I'm going to have to take 2.5 million rows. I'm going to have to join them up here. But we were able to use that bitmap to cut the number of rows that we had to bring to the join down by quite a bit. So that provides SQL Server a way to do substantially less work when this hash join. So that's a place where a bitmap was useful. We were able to reduce the number of rows that we had to join together. And this is a place where the bitmap is far less useful. Look at the execution plan here. We will have a bitmap in the exact same place. Exact same place in the credits. It's amazing the way that works. But over here, we can see that SQL Server was like, oh, I'm going to need 2.4 million rows, and I'm going to end up reading all 2.4 million rows. That bitmap did not actually help us filter any data out. Every single user ID that we saw from the badges table, right? We see that hash key down the bottom, user ID. Every single user ID that we saw from the badges table was in the users table. So SQL Server was not able to do a good job of filtering data with the bitmap here. Because of that, we end up doing basically a full join of both tables together. I don't mean like you're doing a full join, like a crazy Cartesian product thing. I just mean that, you had to take all the rows and join them together to figure out which ones matched and which ones didn't. Whereas in the other one, we were able to do a lot of filtering beforehand and join fewer rows together.
Hey, Eric, can I interrupt you for a second?
Fine.
So one of the one of the things in query tuning, you might compare like estimated and actual row counts here. So you might look at this query, you look at that clustered index scan, the estimated and actual row counts kind of match up, and you're like, oh, I guess that's good. When really it's like, oh, it actually means that bitmap sucked.
Right. Yeah.
Okay.
So this is a case where the bitmap was not helpful. In the other case where you might look at this query, and you might look at this query plan, and you might think, haha, the optimizer sucks. Look at what a terrible job it did of estimating how many rows. That was actually the bitmap being useful.
Okay.
If you look at the estimated and actual here, it's not like the optimizer was wrong. The optimizer made its guesses. Then the optimizer stuck a bitmap in the execution plan, and that bitmap turned out to be, I don't know, super effective, whatever nerds say. And then and then when it applied that bitmap, it was able to filter a lot of stuff out. So that was a helpful bitmap, kind of making the optimizer look bad. It was like,
okay, cool,
we're really good friends, but he's embarrassing when he gets drunk. Not that you would know anything about that. So one kind of funny thing is that not every bitmap will hit this scan operator. I've got this kind of funny looking query here, which is using a not exists between users and comments. And this one is a little bit interesting because there is, on the inner side of the hash join, there's an aggregate right here. And even though the optimizer is capable of pushing bitmaps past aggregates, it doesn't always do that for some reason. I don't really know why. I asked Paul White, and he's been ignoring me ever since, but whatever. But here we can see that if we look at the index scan, there is no bitmap that touches over here. But if you look at the repartition streams operator, there's a bitmap in there. We can see that there's a predicate on the repartition streams. This is just way out wiggy weird stuff. And I don't know, it made me crazy when I saw it. And I was just like, what? No. and I really have stopped writing demos since this one. Just terribly distressing. Are there any other questions on this before we forge ahead?
I mean, that was super helpful to me.
Yeah, cool.
Any questions coming? Got no questions coming in
No.
at the moment, so
Right.
Keep going.
Cool. All right, let's boogie then. So one of I don't hate spools. I hate what spools mean. So one of my least favorite query plan operators, whenever I see one, is a spool. It doesn't matter what kind of spool it is. It could be a table spool. It could be an index spool. It could be a row count spool. Whenever I see a spool, I get nervous because something weird is going on in that query. SQL Server said, I have examined all the alternatives, and creating my own temporary object seems like the best one. And oftentimes that signals that we as query writers have failed significantly in some way. Now, I have a lot of material on spools on YouTube for free. If you go search through things, you can go learn a lot about spools there. This is one that I think is kind of interesting because it's not your normal everyday, like I was trying to read data in a dumb way and SQL Server spooled and hurt me. This is when a spool in a modification query can be avoided. And we can get better performance from modification queries. Now, one reason why tuning modification queries is important, of course, what do modification queries do? Lock data. What do we want to avoid? Locking and blocking. Why? Because when users are like, yes, when users are like, hey man, my query is slow, and we're like, yeah, what do you want me to do about it? And like you go look at what's happening, and there's blocking, and you're like, oh well, here's why, and you try to like say something smart to them about blocking, and they're just like, no, just fix it. We want to get ahead of these problems. So we have kind of a funny looking update here. And the point of the update is just to get the max score from this total score by user table. And the kind of funny thing about that though is that the columns that we need to get the max score from are both in the table that we're updating. So when we run this query, we try to get this table to update itself. I'm like, okay, the boss said I can't write a trigger, so here I am writing this. Or maybe you would put this in a trigger, and your life would just be significantly worse every time someone put a row in this table. Imagine every time you had a row in this table, you had something that ran for like 6 seconds. You would get fired. So I'm kidding. No one ever gets fired. No one gets fired, and no one ever deletes data. It's like the two worst things about databases. So if we look at what happened here, you might look at this and say, well, 6 seconds, man, that stinks. And you're like, yeah, okay, fine. But let's trace things back a little bit. Let's start over here, because over here, we don't spend a lot of time doing anything. Like you might think like, oh, just add an index, it'll be faster. Where? Whenever we touch indexes, it's fast. When we join those indexes together, it's fast. When we aggregate things, it's fast. When we do this other cluster index scan, it's fast. When we join that together, we're still only at 1 second. We spend about 2.5 seconds inside of this spool, and then about another 2.5 seconds inside of this update. That's fishy to me. We have this spool here because SQL Server needs to keep track of rows that it's going to update. This is something called Halloween protection. It's all over modification queries. And usually there's just not a whole lot you can do about it unless you see this kind of awful spool here. Now, what we're going to do is we are going to make our own spool. And our own spool is going to be called the temp table. Now, it's not that spools are bad, again, it's just that spools aren't really optimized the way a lot of other things in SQL Server are. For example, if you dump data into a temp table, there are all sorts of fun optimizations that SQL Server can do, like say not inserting data row by row into them like you do inside of a spool, or like all sorts of cool logging optimizations that can happen when you insert data into a temp table and not a spool. I don't know how spools fell so much by the wayside, where temp tables have just gotten all this love. Like if Microsoft would just fix spools, I would almost have nothing to complain about. So let's reset the table a little bit, and let's that. And now what we're going to do is we are going to create our own spool. Right? We're going to drop it if it exists. It's fancy, I know, new syntax. Drop table if it exists, but we're going to create a table called update. Right? Fairly standard table. We're going to insert data into that table, and then we're going to update. We're going to update our base table from that temp table, right? So where it looks like we have a whole lot more work to do, we actually end up doing a whole lot less work, right? I'll run that one more time for good measure to prove that there's nothing weird going on here. If we go look at the execution plan, the insert into the temp table took 1 second. Remember that insert into the spool took about 2.5 seconds. What the hell was SQL Server up to? I don't know. Not doing things as well as when we put them into a temp table. And if we look at the second query where we did the update, that took 1 second. So if we look at these two queries combined, we are at under a second and about a second. So we're down to 2 seconds from like 7 seconds of trying to update things and dealing with that spool. That sucks. I hate that. And this is one of those reasons why when I see spools and execution plans, I get nervous. Now, half of the reason why Joe Obish gets a 50% discount code is because he whispers smart things in my ear once in a while, and occasionally I'm sober enough to understand. And this is one of those times where he said, well, you know, there are other ways to create spools, and then he stopped talking. I think he went to go watch anime. It was very depressing. Are there any questions about that? Or we go do something else? Yes, no, maybe?
No questions coming
All
in
right.
at the moment.
Okay, so let's talk about a different problem. And this is a problem of a lot of times when I'm working with clients that they will have these very extravagant queries that do a lot of things and think very hard about a lot of stuff that might happen within a database. And they're like, this is really slow. Like we don't know what happened. It was really fast. Everything was chugging along wonderfully. And then we added this part in the where clause, and everything sucks now. I'm like, okay, let's take a look at it. All right. So right now we have this index, right? We have this index on the post table on ID that includes our user ID. And the where clause will always look something like this. And it'll say, well, look, we need to figure out if less than 30 days have occurred between the current date and something else, or more than 30 days. Some it doesn't really matter what. I could explain this code all day long. Just take a look at what's happening here. Our where clause is it has the date diff function, and that date diff function has the creation date column inside of it. All right. So let's run this query. See what happens. Let's go crazy, right? What's the worst that could happen here? What are you going to do? Fire me? When we look at the execution plan, this thing runs for about 2.5 seconds total. What the entire plan does is kind of irrelevant to this. It's just a matter of timing. If we just want to A/B test different changes within a query, maybe the execution plan isn't something that we stare at. We just like, we're going to make a change and see if things get better. Then we'll compare the execution plans and see what happens, right? So we have this first query here that runs for 2.5 seconds. And then if we come down here and we write our where clause in a slightly more sane way. So rather than wrapping our column inside of that date diff function, what if we just wrap a literal inside of a function instead? What if we approach the problem a little bit differently? What if we stop making it the columns problem and we start making it this literal values problem? So rather than seeing if the column has a less of a differential between some literal value and having our filter out here, what if we say, if we subtract 30 days from this date, is the column greater than that? Well, that's a little bit snappier to me. Let's run those side by side. Now, I didn't change any indexes. I didn't do anything weird or goofy. I just changed the where clause a little bit, and we go from a query that takes let's call that 2.6. I'm gonna kick that one in the nuts for 5 milliseconds because I'm so angry at it. We have a query here that takes 2.5 seconds and a query down here that takes 1 second. If we started adding indexes, like actually giving a SQL Server something useful to find that data in, we could tune this query even further. But a lot of times just making small changes to a where clause, like not wrapping columns and functions, can have a pretty big impact on how long a query takes. Is our job done here? Probably not, but this is a good first step, is getting something to run a little bit more than twice as fast. And that was all just from taking the date math and doing it in a slightly different way. And again, not making it the columns problem, we're going to make it the values problem. Any questions on that?
I don't see anything coming in.
No? All right. Since we have about 5 minutes left, I want to make sure that I show you guys the demo that Joe was really into. And this was Joe's favorite demo that I ever showed him, because he didn't understand it. And that to me, that's a sign of a good demo. So I'm going to apparently create this index. And while I create this index, I'm going to talk to you a little bit about predicates, because they're important, right? They're how we find data, or how we get to where we're going in a query, right? They're how we find things. So I have this view here, right? And this view is going to have a window function in it. I know. Very repetitive, very unrealistic to ever have a window function anywhere. But this view is just going to create a rank of scores for a user, right? So we're going to partition by owner user ID, we're going to order by score descending, and we're going to figure out each user's highest score for something. That's all we need to do. And if we, I'm pretty sure I already have this view, but who knows? Let's play it safe. Let's not get crazy here. If we run a query against that view, and we look for a single user, this will happen really fast, right? It's about as fast as you can ask a query to go. If we look at the execution plan, almost zeros. Very, very close to zero. Does not get. I'm willing to bet that if we didn't get an execution plan, that would be a little faster. But because we're doing demos, we have to look at execution plans. Here we are, right? So there's our execution plan, and there's our very fast query execution. Now, the next thing that we might do, because we are diligent, we are studious database administrators and developers, we might polish some ivory and say to ourselves, well, the fastest way to execute a query is with the stored procedure. Everyone says, like, get your entity framework out of here, get your nhibernate out of here, get your whatever other homebrew ORM you are thinking about using out of here. And let's wrap that view inside of the stored procedure. We're going to say select star from our view, but now we're going to make this thing usable for everyone. Any user can come along and say, I want to look at scores for some user ID. Maybe it's me, maybe it's someone else, maybe I want to compare, I don't know. But now we have this stored procedure. And now when we run this stored procedure, which are inherently superior to all other forms of query execution in a database, the best way to run a query, this is not quite as fast as it was before. We might even call this a significant slowdown in query execution, to the tune of about 5 seconds. So we went from a query that ran in almost nothing, right? As close to nothing as you can humanly conceive of, unless you're like Honey, I Shrunk the Kids, and you can like get really small and travel through time. But this is a very very big slowdown, monumental slowdown. If I knew math, I would compare this in orders of magnitude, but I don't. I have no idea what that means, but I assume this is at least one of them. Correct me on that if I'm wrong, Jake. I assume this is at least one order of magnitude. You don't have to give me an actual number. Just more than one is fine. So what happened? What is different between these executions? Let's look at the query plans side by side, right? We're going to get the slow one. We're going to get the fast one. We're going to figure out just what happened here that made things go so amok for us. Right? And if I learn how to click, this will go even better. So what's that top execution plan doing? That's scanning our non-clustered index, segmenting, projecting a sequence, and then filtering. We don't have that problem down here. Here we seek, we segment, we project a sequence, and we're done. What gives? What are we filtering up here? Why did we scan this whole thing? Why did we scan all 17 million rows instead of just going to the 27,000 rows we care about? What happened, SQL Server? What's wrong with you? What's on your mind? Why am I paying $7,000 a core for you to be dumb? Well, that predicate is on user ID, the parameter user ID. And this is an unfortunate thing that happens with windowing functions, right? Remember, if we go all the way back up here to where this code was, when windowing functions run, the way that they run is they have to sequence data. They have to put data in the order of any partition by columns. That's one sequence, and then they have to sequence data in the order of any order by columns within the windowing function. That's the other sequence. Then you have, so that's the other segment. Then you have that sequence project. And the crazy thing is that with literal values, SQL Server can take them and push them all the way over here. If you look, there's a seek predicate on 22656 at the bottom down there. Right? Cool. Great. Why can't you do that with a parameter? Oh, just can't. It is a failing, it is a limitation in the query optimizer. It is not something that we can fix unless we stop using views. Because views don't take parameters, but you know what does take a parameter? Stop me if you've heard this one before. An inline table valued function will accept a parameter. So if we change the way that we go fetch data a little bit, we're gonna create a function that returns a table. This is not one of the bad kinds of functions. This is not one of the evil scalar or multi-statement table valued functions. This is an inline table valued function. And we're gonna have that inline table valued function take our user ID parameter. All right, we can go create this. Oh, good stuff here. Get that all figured out. Nothing else changes about the logic in here except that our where clause is here now. And we're still gonna wrap that inside of a stored procedure. So this is gonna use our function, right? So we're gonna create this thing because I'm pretty sure it's there, but you know, looks like not get cocky out there. And we're gonna run these two queries. And we're gonna see that one of them is very fast. The other one is very slow. But that's something we kind of knew before, that this first query takes about 5 seconds. This bottom query is back to being very fast again. So if you're designing views, if you're designing queries that need to do anything analytical, that need to filter on windowing functions, that need to do anything like that, be very, very careful with where you place them. I see a lot of people stick things like that inside of views because they're like, I just don't want to have to write that query over and over again. I have my query in a view. We'll just let people use it from there. Everything's good. Not when you do that. As soon as you involve windowing functions and you have a where clause in there, SQL Server can no longer push predicates past that sequence project, and performance goes to hell. So stop doing that. This is a very, very good use case for inline table valued functions. So a view is just a query. Remember that. Views do not inherently materialize data. They don't, put anything in solid forms or shapes. They're just little thoughts inside of your database. They're not physical things. Parameters can't be pushed past sequence project operators. As soon as you have a windowing function, you're going to have a sequence project. Excuse me, I promise no one's getting sick from that. But parameters can't go past there. Literal values can. If you have a literal value, the optimizer is like, cool, come on in. Filter your data over here. But parameters, variables, no dice. inline table valued functions can accept parameters, and because of the way that they're designed, which is basically like an inline view, there's no real parameter sniffing worry with them. Everything is basically a literal value to them. And those can take a parameter and push it to the index access. And I guess that's about it. Any questions on that?
Great. Any questions coming in here?
Are there any questions in general? You can be honest, Jake.
Yeah, I guess as long as we're, yeah, I was gonna say, can you put that back up?
Yeah, there you go. I read your mind.
Just to reiterate to folks, and also just erikdarlingdata.com.
Yep, that's my website.
Right, and if
for now anyway.
For now,
we'll see if the domain registrar repossesses it.
Oh, so I don't know. I mean, I would just plug your like bite-sized video blogs are also pretty great.
Yeah, sure. So, you know, if you go to that bit.ly link, you'll see these demos and even more. I have like 20 of them in this series. Over on YouTube, they're all dead free. I also have, I don't know how many days of material over there. Just stuff that I like to record, have fun with. And again, I just released a lot of way more in-depth performance tuning training stuff. I don't mess with HADR or anything outlandish, just all SQL Server performance tuning stuff. If you're interested in that, use the coupon code Joe Obish, 50% off your entire order. Doesn't matter how much or how little you get. But yeah, it's there, and it's for a good cause, which is to keep my wine fridge.
And when will you start selling merch?
Merch?
Yeah.
You know, I have stickers that I'm happy to give away for free, but there's just this lack of places to give them away right now.
Yeah,
so as soon as I have a place to give those away again, I will start giving away stickers. I have some amazing new. I still have some of those temporary tattoos, but I have a lot of stickers. I have a lot of new stickers since the last time I saw you. I got holographic ones. I got ones where Paul White said I was right about something. It's fantastic. Got all the stickers.
Great.
Is it?
There's
a very non-committal great.
No, I'm looking at what's going on in the chat. Like, there's some very
reading email.
No, I'm not reading emails. I'm trying to ignore Joe sending me messages.
That's good. So, I'm ignoring children screaming. So we're about in the same place.
I guess a general question of what is a good way to tell which operator is more efficient in a query plan? Like, for example, if a query plan show that two query plans are both using an index seek and then a hash match, and the hash matches show a different percentage of the cost.
Yeah, again, don't get caught up on percentages anymore. Or ever really. Percentages aren't going to solve a problem for you. If both queries are doing an index seek and then a hash aggregate, then probably the issue is not with a percentage. The issue is probably with some way that SQL Server decided how to allocate resources in that query. So like if both are doing a seek and then a hash, then my question becomes, well, how much memory did those hash operators get? Is that really the choke point in the execution plan? Is there something else downstream? Did SQL Server make a bad guess about how many rows it could actually aggregate at those operators? And is there some downstream effect with like that poor estimate that is hurting something else in the plan?
Mm-hmm. And I'll say, like, one of the lessons I just learned today would be like, how can I tell if that bitmap was efficient?
Yeah.
Right. I compare that actual and estimated rows where I see that bitmap actually being applied.
Yeah, that's a question would be one
way to show me.
And actually, you know, it's over on my YouTube channel. If you follow that bit.ly link, you'll get there. I have a playlist of videos that I call Angry Aggregates, where I look in detail about a few situations where aggregates have some pretty severe issues with estimates and how they can pass those estimate defects along to other parts of the query plan.
Awesome.
Cool. Anything else in there?
No, nothing else coming in. I will say, like, this was awesome. I'm really glad you were able to do this. Like, I guess it's one saving grace of the pandemic, because there's no way I was going to be able to make you fly to Madison to come.
No, but
For one night.
you could start having remote presenters now for these things, because it is a technical possibility.
Yeah, there you go, Brigitte. Like, we should really consider bringing in more remote people. If the quality is going to be as low as Erik, I mean, we might just.
Yeah, I mean, don't look at me as the bard. You might want to get someone smart next time.
You are getting a lot of thank yous from people here.
Oh, good.
So people are appreciative.
Cool. Thank you for
awesome.
having me and watching.
Thanks a lot for
staying
doing this.
Awake.
Yeah, thanks for
I'm impressed. All right.
One more question, actually, Erik.
Yeah.
For how long can I use that coupon code?
Forever. For as long as Joe Obish is my friend. So
so one more week.
We'll see. I don't know. I'm going to have to talk to him at the end of this and see where things stand. But as long as Joe is my friend, you can use that coupon code.
All right, great.
So you might need to start bribing him in other ways. All right. Anyway, thank you for having me.
Thanks,
have
man.
a
really
good night.
Appreciate it.
Enjoy the rest of your pandemic vacation, and okay. I don't know. I will see you next time.
Great. All right. Thanks everybody for coming. Thanks again to Erik, and please connect with us on Twitter and email us madpass@pass.org if you have more questions. And
slide into those
back
DMs.
to you. That's right. All right. Have a good night, everybody.
Bye.
All right. Thanks a lot.